sir.
Can you, very good. Can you see the
Yes.
screen well? पूरा स्क्रीन आपको अच्छे से दिख रहा है? चलिए
Yes,
बच्चों,
sir.
देन थोड़ा सा
Yes,
रिवीजन
sir.
करके आगे चलते हैं. कल हमने जो पढ़ा उसी का थोड़ा सा रिवीजन करते हैं और वैलेंसी के बारे में हमें देखना है. लेट्स स्टडी अबाउट द वैलेंसी. Which elements have their valency 0 and why? We have studied that noble gases or inert gases like helium, neon, argon, krypton, xenon, radon, etc. have their valencies 0. Now, how? So let us study that as they have completely filled outermost shell or valence shell, that is why their valency is 0. Why they have valency 0? Because their outermost shell or valence shell is completely filled. If you look at neon, the electronic configuration is 2 8, and that is why valency is 8 minus 8 is equal to 0. If you look at argon, the electronic configuration is 288, the valence shell is completely filled with 8 electron, and that is why the valency is 8 minus 8 is equal to 0. Remember, ये चीज आपको याद रखना है. That is what you need to remember it well. That helium, the electronic configuration is 2, but we know that K shell has maximum 2 electron that can be filled in K shell. So here, the K shell has completely been filled, and that is why the valency of helium is considered to be 0, which has 2 electrons in its outermost shell, but outermost shell is completely filled, and that is why the valency is considered to be 0 for helium. Please remember, the valence of helium is 0 because the K shell in helium is completely filled. Valency of which two elements should we remember? Now we need to remember the valency of two elements. First, we need to remember the valency of helium, which is uh, the valence shell electron is 2, but my dear students, its valency is 0. Same way, my dear students, phosphorus show two type of valency. The valency of phosphorus is 3 and 5. Please remember, when we look at the electronic configuration of phosphorus, it is 2, 8 and 5, my dear students. So looking into this, the valency should be 5 minus 8, that should be minus 3. So the valency should be 3. But this 5 also is there because the number of all this electron can be lost away, and that is why it is the exception, or we need to remember that the valency of our phosphorus or our phosphorus show two type of valency. One valency of phosphorus is 3 and another valency of phosphorus is 5. So these two we need to remember. These two valencies we have to remember, that though the number of valence electron present in helium is 2, but its valency is 0. And phosphorus show two type of valency. One is valency 3 and another is valency 5. This valency 3 you get it by 5 minus 8, and this valency 5 is equal to number of valence electron present into the phosphorus. So phosphorus show two type of valency that can be obtained using both the formula to calculate the valency. Now let's move and understand the next point. The next point says what is octet and why do atoms react. How do atoms achieve octet? These three things we want to understand. So first understand what is octet. An outermost shell which has 8 electrons is said to possess an octet. We know that in the outermost shell we can maximum fill 8 electrons. So this outermost shell which possesses 8 electrons is said that it has completed octets or it possesses octet. Atoms react to achieve an octet in their outermost shell. Now the question, next question, why do atom reacts? What is octet? When we have 8 electrons in the outermost shell, we can say that the atom possesses octet or octet is complete. Next question, why do atom reacts? So all the atom reacts to achieve their octet in their outermost shell. That means what happens? Suppose you have electronic configuration 2 6. So this electronic configuration try to become like 2 8. If you have electronic configuration 2 8 3, or if you say if you have electronic configuration 285, it would like to become like 288, or it may like to become like 28, or it may also try to become like 2. So you can see that, my dear students, each and every element tries to make their electronic configuration or try to make their outermost shell to have 8 electrons in them. So that is why each and every element try to become like the element of inert gases, or they want to achieve the octet, and to achieve the octet they react with each other. Next question. How do atom achieve octet? अगर किसी atom को octet achieve करना है तो कैसे करेंगे? How do they achieve octet? So atoms by sharing electron first thing, by gaining electron and by losing electron. These are the three ways. Atoms can achieve octet by sharing electron, by gaining electron or by losing electron. So atoms by sharing, by gaining or losing electrons achieve octet in their outermost shell. Please remember my dear students that atoms by sharing electron, gaining electron or losing electron achieve the octet. Someone has drawn a line, please remove it. I think it was Krishna who has done it. Krishna, please remove it. I cannot remove it. So atoms by sharing, gaining or losing electrons achieve the octet in their outermost shell. Now let's try to understand the next one. Uh, let us see what is there in the next one. Okay. So what is the next question? Let us look into. Helium atom has an atomic mass of 4U and 2 protons in its nucleus. How many neutrons does it have? So see, atomic mass A they have given, and that is your 4. A is given as 4. 2 protons. 2 protons means Z is equal to P is equal to 2. So now we need to find out neutron N. We know that N is equal to A minus Z. Please remember, my dear students, N is equal to A minus Z. That your A is equal to 4 and your Z is equal to 2. So it will have 2 neutrons. That is what we can easily understand. Now let us see the answer. What is written into the answer? Here given atomic mass A is equal to 4U. Now number of proton P is equal to 2. That means number of proton represent the atomic number Z, and that is why the atomic number for this helium is 2. So we know that number of neutron is equal to atomic mass minus atomic number. So N is equal to A minus Z. That means 4 minus 2, because A is equal to 4 and Z is equal to 2. And that is N is equal to 2. It means that helium nucleus possess 2 neutrons, my dear students. Now let's move forward and understand the next. Write the distribution of elements, distribution of electrons in carbon and sodium atom. So we have 2 atoms. One is carbon, another is sodium. So first we will write the element. So we have carbon element and sodium element. Then we will write about, my dear students, then we will write about the atomic number. So a carbon atomic number is 6 and sodium atomic number is 11. Now, my dear students, we are well aware that in K shell we can maximum fill 2 electrons. So we have filled 2 electrons because the atomic number is more than 2. So now, my dear students, if we take 6 minus 2, if we take 6 minus 2, we will get 4. So now in L, we can fill up to 8 electrons. So 4 is being left, and that is why we will put 4 here. But in the case of sodium, if we think about, then my dear students, 11 minus 2 is equal to 9. So in the next L shell, we can fill up to 9 electron. But we know that in maximum in L shell, we can fill 8 electron. So out of 9, my dear students, we have filled 8 electron in that. So now, my dear students, 9 minus 8, which is equal to 1. So in the next shell M, we will fill 1 electron. So my dear students, we can now understand that if the atomic number is 6, in the K shell we have 2 electron and N shell we have 4 electron. If the atomic number is 11, in the K shell we have 2 electron, L shell we have 8 electron and M shell we have 1 electron. So let us understand one more, few more examples or next question. If K and L shell of an atom are full, then what would be the total number of electron in the atom? Now suppose we have this question, my dear students, that if the K shell is completely filled, then what is the number of atoms that possess. So my dear students, maximum number of electron in shell is equal to 2n square. So for K shell, my dear students, n is equal to 1. So maximum number of electron is equal to 2 into 1 square, that is 2 electron. If L shell, n is equal to 2, so maximum number of electron is equal to 2 into 2 square, that is 2 into 4, that is 8 electrons. So if K and L shell of an atom are full, then we can say there would be 2 plus 8, that means 10 electron in the atom. So if this is the question, my dear students, we can easily answer that if K and L shell of an atom are completely full, then what would be the total number of electron in the atom? So if K and L shell are completely filled, then there would be 10 electrons in the atom. Now, my dear students, we want to study about the next one, which is, let us read the question. Find the valency of chlorine, sulfur, aluminium and oxygen. So to find the valency, we need to first let us write the name of these elements. So we have the element chlorine, sulfur, aluminium and oxygen. Then we'll write their atomic number. For chlorine it is 17, for sulfur it is 16, for aluminum it is 13 and for oxygen it is. Now if we write their notation, my dear students, we would come to know that it is 17Cl35, 16S32, 13El27 and 8O6. Now looking into the their atomic number, my dear students, we can easily write the electronic configurations. So for 17, K has got 2 and L has got 8. So 2 plus 8, 10. 17 minus 10 is 7. So in the M shell, we will have 7 electrons. So in case of 16 atomic number, first we will put 2 electron in K. So it is 16 minus 2. That will give us 14. Then in the L shell, we can fill 8. So 14 minus 8, my dear students. So we get 6. So remaining 6 we fill into the M shell. So this is how we can understand the electronic configuration of sulfur. Now let's look at the aluminium. So first, in first shell we can put 2 electrons. So it is 13 minus 2, which is 11. Then in next cell we can fill 8 electrons. So 11 minus 8, that is 3. And then the last 3 we can fill into the third shell. So this is how, my dear students, we understand the electronic configuration. Same way in case of oxygen 8, in the first shell we put 2, so 8 minus 2, that is 6. This 6 is less than 8 and in L shell we can fill 8 electron and that is why we put all 6 electron into the L shell. So this is how, my dear students, we understand the writing of the electronic configuration of any element if their atomic number is known. Now here you can see that we want to find out first the number of valence electron. Valence electron, to find the number of valence electron, we will have to find out the outermost shell or valence shell. Valence shell is the outermost shell of the electron. So for oxygen, the outermost shell is L. For aluminum, the outermost shell is M and it has 3 electron. For sulfur, the outermost shell is M and it has 6 electron. For chlorine, the outermost shell is M and it has got 7 electron. So we can write the valence electron 7, 6, 3 and 6. Now we know we have to find out whether the number of valence electron is greater than 4 or less than 4. So here 7 is greater than 4, 6 is greater than 4, 3 is less than 4 and 6 is greater than 4. Now we use the different formula for the different number of valence electron. If number of valence electron is greater than 4, then the valency is equal to number of valence electron minus 8. So here we will use the formula number of valence electron minus 8, that is n minus 8, which is 7 minus 8 and the valency is minus 1. If here also the number of valence electron is greater than 4, so we will write n minus 8, that is 6 minus 8, that is minus 2. Here n is equal to 3, that means it is less than 4 and that is why we can easily say that the number of valence electron, it is less than 4, my dear students. So the number of valence electron is equal to the valency and here the valency is plus 3. And if you look at the oxygen, it has 6 electron which is greater than 4 and that is why the number of valence electron minus 8, that means n minus 8, that is 6 minus 8 and that is why the valency is minus 2. Please remember that these signs are just showing that what kind of ion they will produce. So we can say that the valency of chlorine is 1, the valency of sulfur is 2, the valency of aluminum is 3, and the valency of oxygen is 2. But oxygen will make O minus 2 ion, aluminum will make Al plus 3 ion, sulfur will make S minus 2 ion, and chlorine will make Cl minus 1 ion. This is what we understand by putting this sign. So this sign is also very helpful to understand the nature of an atom. Now let's look at the next question, my dear students. If the number of electrons in an atom is 8, suppose we have in any atom, if we have the number of valence electron is equal to 8. If the number of electrons in an atom is 8 and the number of proton is also 8. So you can see that number of electron is equal to 8. Number of proton P plus is equal to 8. Then what is the atomic number of the atom? So we know that atomic number is represented by the number of proton, and number of proton is 8, and that is why the atomic number should be 8. And what is the charge on an atom? Now you can see that proton has got plus 1 charge and electron has got minus 1 charge. So 8 into minus 1, that is minus 8. 8 into plus 1, that is plus 8. And we know that plus 8 minus 8 is equal to 0. That means there will be no charge and the atom will be electrically neutral. This is what we can, or this is how we can answer the question. Now let us see what is written into the answer. Here given that number of proton is equal to 8 and number of electron is equal to 8. Atomic number Z is equal to number of proton, and that is equal to 8. And that is why the atomic number of an atom is 8. Now let's think about charge. A charge, how can we calculate the charge? The charge is equal to number of proton minus number of electron. Please remember, charge is equal to number of protons minus number of electrons. So here the number of proton is 8 and number of electron is 8, and that is why the charge is 0. Please remember this formula, my dear students, that charge on an atom is equal to number of protons minus number of electrons. That is the formula to calculate the charge. Here the charge on an atom is 0. It means that the atom is electrically neutral. Now next question. Find out the mass number of oxygen and sulfur. So we need to find out the mass number of our oxygen and sulfur here. So let us find out the mass number of oxygen and sulfur. Mass number is equal to number of proton plus number of neutron, that is A is equal to P plus N. Now when we look at oxygen, my dear students, oxygen has got atomic number 8, that is 8 proton, and the number of neutron present in oxygen is equal to 8. So my dear students, the atomic mass number is equal to 8 plus 8, that is 16, and that is why the mass number is 16. Now for sulfur, my dear students, we can see that it has got the atomic number Z is equal to 16, that is proton is equal to 16, and we have seen that the number of neutron also present in sulfur is equal to 16, and that is why A is equal to P plus N, that is 16 plus 16 and 32, and that is why the mass number of sulfur is equal to 32. Now you may think that, sir, from where did you take this number of neutron and proton? That, my dear students, we have already studied about these all elements, and I have shown you all the pictures, and from that picture we have taken this data. So you can see that once again the picture of that. You can see here we have the picture of sulfur, and in sulfur you know that we have 16 proton and 16 neutron. Same way if you look into the oxygen, my dear students, we would come to know about the oxygen. Here we have this oxygen. And when we look at the oxygen, we come to know that we have 8 proton and 8 neutron. So in these pictures, I have explained about everything of this atom. And from that, we can answer these various questions if they are asked to us. It is better if you learn those pictures very well. So now let's move forward and understand the next question, my dear student. What is isotope? It is a very important question and IMP question for your exam. Please study about isotopes, my dear students. So what is isotope? Atoms of same element. Please remember that isotopes are the atoms of the same element with the same atomic number. That means they have Z. Atomic number Z is equal to same. but different atomic mass number are called isotop of each other. Once again, please remember, what is the definition of isotope? Atoms of the same element with same atomic number but different atomic mass number is called isotope. One more time, atoms of the same element with same atomic number but different atomic mass number are called isotopes of each other. Now there is one more important thing to note down, that isotopes have same number of protons but different number of neutrons. Please remember that isotopes have same number of protons but different number of neutrons. So when we study the definition of isotope, they have Z is equal to same. So Z is represented by number of protons, and that is why these two isotopes have same number of protons. But their A is equal to different. That means their atomic mass number is different. That atomic mass number is different because they have the different number of neutrons, and we can say that isotopes have same number of protons but different number of neutrons. So that is how we study about isotopes. Give three examples of isotopes. So my dear students, here we are going to study about the three examples of isotopes. The first example is a very important example. These all are the three isotopes of hydrogen. So we'll study the three isotopes of hydrogen. One isotope is known as protium, which is represented by 1H1. The second isotope is known as deuterium, which is represented by 1H2. And third isotope is written as a tritium T, which is represented by 1H3. Please remember, my dear students. Sometimes they also write 1D2, or they can even write 1T3. My dear students, we are well aware that we write Z, then the element and A. That you can see that for all this protium, deuterium and tritium, they have their atomic number same. You can see that all these three, 1H1, 1H2, 1H3, they have their same number of protons, or their atomic numbers are same. They only have different atomic mass number. Now, how do we find the number of neutrons, my dear students? That we know that number of neutrons can be found out by the N is equal to A minus Z. So here when you look at protium, my dear students, your A minus Z is equal to 1 minus 1, and that is equal to 0. And that is why protium has N is equal to 0. That means it does not have any neutron. Now, my dear students, when we think about the next one, that is deuterium, we know that A for, see, A, Z, X. So here Z is equal to 1, my dear students. A is equal to 2. So your number of neutrons is equal to 2 minus 1 is equal to 1. So you can say that deuterium has 1 neutron. Now if you look into the tritium, my dear students, we can come to know about, tritium has your A is equal to 3 and Z is equal to 1. So we can write A is equal to 3 and Z is equal to 1, and that is why 2. So my dear students, tritium has 2 neutron, deuterium has got 1 neutron, and protium does not have any neutron. Next example, my dear student, we study about the isotope is the isotope of carbon. You can see that we have two examples, 6C12 and 6C14. So even if for these, my dear students, if we write the number of neutrons, which is A minus Z. So for this carbon C612, we can write it as a 12 minus 6, which is equal to 6. So here, in this case of carbon, we have the number of neutron is equal to 6. But if we look into this carbon, my dear students, the number of neutron is equal to N is equal to A minus Z. Here A is equal to 14 and Z is equal to 6. So it is 8, and that is why this 6C14 has 8 neutrons. So this 6C12 has 6 neutrons and 6C14 has 8 neutrons. So my dear students, you can see that both these have same number of protons, but here the neutron is 6, here the neutron is 8, and that is why they have different atomic mass number, and that is why they are called the isotope of each other. Remember that these both are the isotope of carbon, so they are the atom of the same element. Same way you can see here we have 17Cl35 and 17Cl37. So here you can see that your N is equal to 20 and here your N is equal to 18, my dear students. So this chlorine 17Cl35 has 18 neutron and 17Cl37 has got 20 neutron, and that is why they have different neutrons, but they have same atomic number and they have same atomic different atomic mass number due to the different number of neutrons, and that is how they are the isotopes of chlorine. So please learn these three isotopes of chlorine, and then we have the next question. The next questions ask us to write the applications of the isotopes. So where do we use these isotopes? That is what we need to understand. So let us write the applications of the isotopes. Applications of the isotopes. Number one, an isotope of uranium is used as a fuel in the nuclear reactor. So please remember that an isotope of uranium is used as a fuel in the nuclear reactor. Nuclear reactor um, is the factory or machine like things, or is the place where the electricity is produced from the nuclear energy. So please understand the meaning of nuclear reactor. Then we have an isotope of cobalt is used in the treatment of cancer. We know that cancer is a disease, and by using the isotope of cobalt, we find out that in which body part we have a cancer, and that is why the isotope of cobalt is used in the treatment of cancer. And then we have an isotope of iodine. An isotope of iodine is used in the treatment of goiter. Goiter is a disease that takes place into our throat, where we have the gland, and this gland just uh, swollen up, or this gland has got an inflammation, and inflammation of that gland is known as goiter. So it's a disease, and the isotope of iodine is useful to treat this disease known as goiter. So please remember that isotope of uranium is used in the nuclear reactor, whereas isotope of cobalt is used in the treatment of cancer, and isotope of iodine is used in the treatment of goiter. Now, my dear students, we want to study the next question, and that next question says that what is isobar? So, my dear students, let us study about the isobar. So, isobars are the atoms of different element. Please learn this, that isobars are not atom of the same element, but they are the isotope of different element with different atomic number. Their atomic number will be different, but their atomic mass number are same. We have seen this while we were discussing the first 14 element. We have seen that argon has atomic number 18 and calcium has got atomic number 20, but both these argon and calcium have same atomic mass number. This is what it happens due to the number of neutrons, my dear students, and we can find out the number of neutrons here. In argon, the number of neutron is equal to 14 minus 18, that is 22 neutrons are present in argon, but in calcium we have 40 minus 20, that is only 20 neutrons are present, and thus we can see that they have different number of neutrons, but still their atomic mass numbers are same, so they are called isobars. So now once again let us determine the definition of isobar, that isobars are the element of different atoms which have same atomic which have same atomic mass number but different atomic numbers, and that is why they are called isobars. The wonderful example of isobar is equal to 18 Er40 and 20 Ca40. Isobars have different number of protons. Please remember that this is for very sure that isobar have definitely different number of protons. Now write the electronic configuration of any one pair of isotopes and isobar. So let us study the electronic configuration of all of these isotopes and isobar. So first we will write the isotope of chlorine. They are 17Cl35 and 17Cl37. Their atomic number is 17 and both have the electronic configuration 287. So that means we can say that isotopes have same electronic configuration. Let us look into the another example. Now let us look into the isobars, my dear students. So for isobar, we can write the example 18 ER40 and 20 CA40. So their atomic number for argon 18 and atomic number for calcium is 20. And for atomic number 18, we have the electronic configuration 288, but atomic number 20, we have electronic configuration 2882. So from this, we can say that isobars have different type of electronic configuration, whereas isotopes have same electronic configuration. Please remember that isotopes have same electronic configuration, but isobars have different type of electronic configurations. So now let us understand the difference between write the difference between the isotopes and isobars. So let us write the difference between the isotopes and isobars. Let us first write about isotope. Isotopes are the atoms of the same element and isobars are the atoms of the different elements. Next, isotopes have same number of protons and isobars have different number of protons. Isotopes have same atomic number and isobars have same atomic mass number. Please remember, or we can say that isotopes have same atomic number and isobars have different atomic numbers. Then isotopes have different atomic mass number, but isobars have same atomic mass number. Isotopes have same electronic configuration, but isobars have different electronic configurations. Isotopes have different number of neutrons, and isobars may have same number of neutrons or may have different number of neutrons. Please remember that have same number of isotopes have always different number of neutrons, but isobars may have same number of neutrons or may not have same number of neutrons. And we can write the examples of isotopes, that is 17Cl35 and 17Cl37, but we can write the example of isobar as 18Er40 and 20Ca40. So this is how, my dear students, we study about the isobars and isotopes. Now we have the next question. What is average atomic mass, my dear students? Let us study about the average atomic mass. This is a very important point for your studies, my dear students. So let us study about the average atomic mass. If an element exists in nature in more than one isotopic forms, the mass of the element of the mass of the atom of the element is taken as an average of all isotopic forms related to their percentage or their isotopic form. Such mass is called average atomic mass. Now, my dear students, if you look into the discussion of our class, you will come to know that there are some elements which exist into the various isotopes. For example, we have seen that chlorine exists in the isotopes of 17Cl35 and 17Cl37. Now, my dear student, when we calculate their atomic masses, we need to take an average atomic mass for all these isobars. So first of all, we need to find out in what proportion or in what percentage these isotope exist. And then by knowing this, we can calculate the average atomic mass for these isotopes or for this element. So some element like chlorine, they have their atomic mass into the fraction. So why do they have their atomic masses into the fraction? Because they have or they exist in the nature in the form of more than one type of isotopes. And as they exist in more than one type of isotopes, they can be easily or their mass should be calculated as an average atomic mass. Let us study with an example, my dear students, that for an example, if we look into the atomic mass of chlorine, for example, average atomic mass of chlorine is 35.5 U. So I would like to read the text once again for you. If an element exists in nature in more than one isotopic forms, the mass of the atom of the element is taken as the average of mass of all isotopic forms related to their percentage of their isotopic form. Such mass is called the average atomic mass. Let us understand this with example and then you will understand it better. Write the formula to calculate the average atomic mass. So here we have the formula to calculate the average atomic mass. Average atomic mass is equal to the atomic mass of isotope 1 multiplied by the percentage of isotope 1 divided by 100 plus atomic mass of isotope 2 multiplied by the percentage of isotope 2 divided by 100. So we can symbolically write it as atomic mass of isotope 1 multiplied by the percentage of at percentage of isotope 1 divided by 100 and atomic mass of isotope number 2 multiplied by the percentage of isotope 2 divided by 100. So we can write it in this manner. Now we have the question so that we can understand to calculate the uh, average atomic mass. Chlorine in nature exists in two isotopic form with the masses 35U and 37U. It is in the ratio 3 is to 1. Calculate the average atomic mass. So my dear students, if we are given the ratio, then we will have to convert this ratio into the percentage. Here, my dear students, the atomic mass of isotope 1 is 35U and atomic mass of isotope 2 is 37U. But the percentage of isotope 1 and percentage of isotope 2 are not given. So first we need to find out the percentage. Now how to find out there are some steps by which we can find out the percentage from ratio. So we can say that finding percentage from ratio. So first we need to write the ratio, then we need to take the sum of the ratio. So here ratio is 3 is to 1. So we will write 3 plus 1 is equal to 4. Now we want to find out the percentage of isotope 1. So we will find out the percentage of isotope 1 is equal to the ratio of isotope 1 divided by the total of the ratio or divided by the sum of the ratio multiplied by 100. So you can see that 3 and for 100 we write 25, 4 is 100 divided by 4 and that is how we get the percentage of isotope 1 75%. Then we have the another ratio 1 and that is why we can write that percentage of percentage of isotope 2 is equal to the ratio of isotope 2 that is 1 divided by the sum of the ratio that is 4 multiplied by 100. We know that 100 is 25 multiplied by 4. So these 4 and 4 we can make it 1 or 4 divided by 4 is equal to 1 and we have 25% of this. So now we have the value of percentage A1 and percentage A2. Now we can write simply the formula to calculate the average atomic mass, that is average atomic mass is equal to A1 multiplied by percentage of A1 divided by 100 plus A2 multiplied by percentage of A2 divided by 100. A1 is 35 and percentage of A1 is 25 divided by 100. A2, the atomic mass given is 37. Percentage of isotope 2 is 25% divided by 100. So by doing this calculation for 75 we write 25 3s, for 100 we write 25 4s, for 25 we write 25 and for 100 we write 25 4s, and thus 25 divided by 25 is equal to 1. And we can write 35 multiplied by 3 divided by 4 plus 37 divided by 4. 35 multiplied by 3 you can see here, which is equal to 105 by 4 and 37 by 4. We have same denominator, that is why 105 plus 37, you can do it 105 plus 37, my dear students, and that is 7 plus 5 12, 1 carried, 3 plus 1 4 and 1. So it's 142 divided by 5, which on division, if we divide 142 divided by 4, we get 35.5, and that is why we can say that the average atomic mass of our chlorine is 35.5. So that is what it is written over here, that average atomic mass of chlorine is 35. So my dear students, here we can, this is how we can find out the average atomic mass for any element if their atomic masses are given and the ratio or percentage is given. So if, my dear students, if you have anything to ask about this, you can ask or we can move to the revision. बच्चों, अगर आपको इसमें कुछ समझ में नहीं आ रहा है और आपको कुछ पूछना है तो आप मुझसे पूछ सकते हैं या फिर हम आगे रिवीजन की ओर चलते हैं। कुछ पूछना चाहेंगे बच्चों?
नो सर।
ठीक है बच्चों, तो सब कुछ समझ में आ गया है। अगले पीरियड में हम लोग इससे रिलेटेड कुछ और क्वेश्चन पढ़ेंगे जो कि आपके एक्सरसाइज से है और उनको सॉल्व करेंगे। आपको बहुत मजा आएगा और कुछ और एक्सरसाइज क्वेश्चन को सॉल्व करते हुए आपको मैं कैसे आयंस बनते हैं वो भी अगली क्लास में पढ़ाऊंगा। आई होप यू विल एंजॉय द क्लास एंड आई होप आज भी आपने क्लास को बड़े अच्छे से एंजॉय किया होगा। आई विश यू हैप्पी लर्निंग एंड विश यू हैप्पी डे। हैव अ वंडरफुल डे माय डियर स्टूडेंट्स। आपको कोई डाउट है तो आप पूछ सकते हैं या मुझे व्हाट्सएप पे भी आप